Hey there, I'm Heather Beadle, and today I'm going to be going over some attributes that you can use to detect fluvial systems in seismic data. Some of the ones that are really good are RMS or sweetness attributes that help you find the sand-rich reservoir bodies. You could also use coherence or variance as it's called in some programs. Also spectral decomposition and multi-attribute analyses. So let's look at some examples. So first, let's start off in Alberta, Canada, where we can see some fluvial channels in this time structure map on the top, as well as some of the seismic data that shows those channels in the seismic vertical section below. So now we're looking at the coherence, most positive curvature, and most negative curvature, which show differential compaction over that channel system. We can see that the most positive curvature image exhibits the classic dendritic channel pattern, and we see structural highs with less compaction over the channel axes, indicating that these channels are most likely filled with sand. The most negative curvature image highlights the structurally lower interfluves, which would have been more likely shale. So now we've co-rendered the coherence and most negative curvature, and we can see that this visual integration of both of these attributes clearly delineates the complete system. Now let's move from Canada to northwest Oklahoma, where we can look at a fluvial system, which is a shallow drilling hazard. In this image, we're using coherence to delineate the edges of these very small-scale channel systems. You can also use texture attributes. Here we're using the gray level covariance matrix homogeneity to identify these fluvial systems, which are shallow drilling hazards. And now we're looking at another GLCM attribute, entropy this time, which also allows you to image those fluvial systems. As always, thanks for listening, and if you are curious about more seismic attributes or want to learn more about these, you can visit our website,